Hi, everyone. What I want to do is go over collected homework 2. I have not graded them yet, so don't know how everyone did. But regardless, still, I'll go over this. Okay, so the first problem, very similar to the lecture problem, a little easier though, in that there is no maintenance costs for the machine. So you have a 3-year period, and you can either buy a machine or you can hire 8 employees at the beginning of the 3-year period. Employee costs of $47.50 per employee at the end of each month for 3 years. You can sell the machine at the end of 3 years for $100,000. What is the maximum price that it makes sense to pay for the machine if we're working with an effective monthly interest rate of 0.5%? All right, so this is going to be like in the lecture, an equation of value. We're going to set the machine costs time valued to be the employee costs time valued. And I think it's just like in the lecture, it's a little easier to take the future value of everything, rather the accumulated value of everything. So time valuing everything at the end of the 3 years, though if you do the present value, it's really not much harder. It's not really harder, I guess it's just a little less to write. So it really doesn't matter. You do present value or accumulated value of everything. It's not much harder either way. All right, so let's draw a time diagram for the employee costs. Definitely don't have to do this, but just make sure there's no confusion. That for this not so great line, but anyway. All right, so this is in months. So 1, 2. So all the way to 36, 35 here. All right, so just one employee is going to be $47.50. I mean, you can multiply it by 8 right now, but I don't really have room to do that. So all right, so this time valued, we think, think kind of like a cruise 35 months of interest. So the time value of $47.50 at the end of the 3 years is $47.50, 1.005 to the 35. And again, remember the logic and why we think like this. When you spend this money, this is money you could have spent and put into an account earning this 0.5% interest rate per month. So when we have expenses, we time value that because because you always can invest your money at some interest rate. So anything you spend on something else is money that could have been invested. And we're assuming that it could have been invested at this interest rate of 0.5% per month. All right, so anyway, $47.50. So for the end of the second month employee cost, that earns 34 months of interest. Again, it doesn't really earn interest. We just kind of think in that way that the value of it at the end of the 3 years is $47.50 times 1.005 to 34. All the way to the very end, second to the last, this accrues 1 period of interest. At the very end, we have $47.50. So this is just very simply $47.50 geometric series, 1.005 to the 36. 35 plus 1. over 1 minus 1.005, 186, 846, 4986. So this is the time value of employees for one employee. Sorry, time value total cost of one employee, time valued total cost of one employee. Sorry. So for 8 employees, just multiply by 8. Six, 8, 6.4986. And you get 1494771,989. Okay, so this is quite easy for the machine. So the time diagram here is very simple. We just purchased the machine. X, we get back $100,000. So just like in the video, costs are positive, so money you get is negative. Just so we don't have minus signs floating around everywhere. Okay. Running out of room here, but that's right. So the machine costs time value at the end of 36 months. Well, this is worth X times 1.005 to 36 at the end of 3 months. And kind of that way of thinking I mentioned, it accrues 36 months of interest in some sense. Well, 100,000 is 100,000 at 36 if we're getting it back at 36 months, 3 years. So it's, we get $100,000 at t equals 36. It's worth $100,000 at t equals 36. Okay, so this is the machine costs here. So clear here. Sorry. Use red. Move this up a second. Sorry about that. Okay, so you set this to be 1494771,989. It's employee costs, time valued. So what you get X is 1,332,663 and 11 cents. Just add 100,000, divide by 1.005 to 36. Okay, so Bank A, problem 2, Bank A offers 5% nominal interest compounded every 3 months. So that means 4 times a year. What's the nominal interest rate compounded every 4 months that Bank B needs to offer to be competitive with Bank A? So for the 2 banks to be competitive, they need the same effective annual interest rate. That effective annual interest rate is exactly specifying the actual growth for each bank. Okay, so Bank A, so we use our formula So we have I4 is 0.05. So that means our formula, 1 plus I4 over 4 to the fourth minus 1. Yeah, I4 is 0.05. So this is going to be 0.05095. Okay. Okay, so again, we want the two banks to have the same effective annual interest rate for them to be competitive with each other. Or rather, Bank B has to offer at least 0.05095 for its effective annual interest rate to be competitive with A. So let's figure out what that means for Bank B's nominal interest rate compounded every 4 months. So every 4 months is 3 times a year. We'll just use our formula for I3 or IN in general. It's N 1 plus I to the 1 over N minus 1. So this is going to be 1.05095 to the 1/3. 0.05011. That's the answer. All right, so problem 3. So just like the video that I made, basically the same problem, more or less. So Jen makes this initial deposit into an account that pays nominal interest rate of I compounded every 4 months. So let's say for Jen, A of T is the amount in the account after T years. Okay. So, yeah, second. So for Jen, right. So let's first get what the effective annual interest rate is. Or the equivalent effective annual interest rate. Okay, so right, so remember in general, it's 1 plus I yeah, compounded every 4 months is corresponds to I3. That's 3 times a year. So it's 1 plus 1 over I 1 plus I3 over 3 cubed minus 1. Well, I3 is I. So this is 1 plus I over 3 cubed minus 1. So if A of T is the amount in Jen's account at the end of T years, well, the initial deposit is X. So it's this equivalent effective annual interest rate plus 1 to the T. So I take this whole thing here, plus 1. Well, minus 1 canceled with the plus 1. 1 plus I over 3 to the T. Okay, so that means that the interest earned in the last 4 months of the 9th year is going to be how much more Jen has in the account after 9 years versus after 8 2/3 years. 8 2/3 years is well, the last 4 months of the 9th year. So we're taking A of 9 minus A of 8 plus 2/3. Really, 8/12 is the last 4 months, or 8 plus 8/12 to 9 years is the last 4 months. So 8 over 12, 8/12 is 2/3. So yeah. Yeah, and you got to be careful with this. The algebra miserably fails if you don't get these numbers right. Not all that much subtlety, but okay. 1 plus I over 3. So now this is just like the video. 3 times 9 is 27. 8 plus 2/3 times 3 is 26. So it's going to be x1 plus I over 3 to the 26th. And just like the video, you factor out an x1 plus I over 3 to the 26th. You get just I over 3. Okay, so for Chris, if B of t is the amount in the account after t years for Chris, it's just simple interest. He deposits 3x initially. With 1 plus IT, same interest rate. This is the simple interest rate for Chris, I. So the interest earned for Chris in the last 8 months of the 9th year, same thing. So it's 3x 1 plus 9I minus 3x 1 plus 8 plus 2/3 I. It's an I here. So you simplify everything, and this becomes just IX. 3x's cancel. It's 26I minus 25I. Sorry, 27I minus 26I is. I'll just write it out. 3x, distribute this, 3x plus 27ix minus 3x minus 24 ix plus 2ix is 26. So it's just ix. Okay. So the interest earned for Jen and Chris are the same. So this thing here equals this thing here. Yeah, so just like in the video, let me put the I over 3 in front. Ix over 3. One plus I over 3 to the 26th equals Ix. So having some pen issues. Oh, there we go. Yeah, so cancel the works. No. Okay. Just cancel the Ix. Multiply by 3. So it's going to be 0.12948. About 13%. Okay, so finally number 4, and I would say this is probably the most important problem to understand. You have to understand equations of value because essentially the rest of the whole course is going to be about equations of value, quite literally. I mean, I do a little bit other stuff during the normal semester, but in the summer course, I kind of have to end a little early. So we're not going to do all that much stuff other than essentially equations of value in a lot of different, a lot of different contexts. So, and when I say that, I mean after force of interest. The next topic is the force of interest. After that, we're going to start annuities. Then we do loans. Then we do bonds, and they're all equations of value. So very important to understand. All right, so draw a time diagram. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so you gotta be a little careful. Beginning of months 1, 2, 3, and 4 is 0, 1, 2, 3. So month 1 is 0 to 1. Month 2 is 1 to 2. The beginning of month 1 is 0. I mean, if you screw that up, it's not a huge deal. I won't take off too much. Okay, so this is the cash in. She pays off this loan with payment of X at the beginning of month 6. So that's T equals 5. So beginning of month 7, 8, 9, 10 is 150. I'm going to date everything, find the time value of everything at T equals 5. You could take the present value or take the accumulated value of everything. It's up to you. As we'll see towards the end of the course, it's more common to basically do kind of this kind of stuff and just take the present value of everything. But, right. Okay, so all this is cash out, what you have to pay, or what Jennifer has to pay. All right, so let's figure out what X is. Okay. So time value everything to T equals 5. So 150 earns 1, 2, 3, 4, 5 periods of interest at 1% monthly interest. 150, 1.01, 5. The 150 at T equals 1, 2, 3, 4 periods of interest. Again, technically doesn't really earn interest. It's just this is the time value of it at T equals 5, and it's easiest to say it earns interest. It appreciates. Has 4 months of appreciation, I guess. It's maybe a better way of saying it, but all right, and the next two, 1.01 cubed, 1.01 squared. That's going to be equal to X. So we have to discount the 150 by 1 month. $50, 1 over 1.01. discount the T equals 7, payment by 2 periods. And again, it's very important, even if you don't want to do it this way, you want to take the accumulated value of everything or the present value of everything. It's very important to understand concept of discounting things. You just have to understand that for this course. All right, so we're going to discount T equals 8 payment, a loan payment by 1 to 3 periods. And last but not least, let's fit it in. 150, 1 over 1.01 to the 4th. All right, and you solve for X, you simply get $36, basically. $36.07. Right. All right, so hopefully this helped, and hopefully this was useful. So any questions, let me know. And yeah, so long, take care. Exam 1 is already upon us. It's going to be put up on Friday, so good luck. Obviously I can't help you on that, but all right, so long, take care, bye-bye.